SwayamPrabha. Digital India. Educated India.
Hello friends, I once again welcome you to the course on automation in manufacturing. We are in week 3 and we are studying how to select or fabricate the required components to develop an automated equipment or a system. In previous 2 lectures, we have seen how to select electrical and electronics components. What are the selection criteria, what are the technical terms which one should understand before taking the final decision about the selection and the purchase of electrical and electronics components. Well, in today's lecture, we will be studying the use of computer-aided design philosophy in the designing of the mechanical components. The outline of this lecture is as follows. At the start, we will study the design synthesis and design analysis. Then we will see what is the difference between modeling and prototyping. So, we often use these words. So, I have developed a model, or somebody will say I have developed a prototype. So, what exactly is the difference as far as the engineering point of view, that we will see. Next, we will see how computers are helping in designing the models or the prototypes. We will see what is the difference between sketching and industrial drawings. The industrial drawings are represented in either 2-dimensional mode or the 3-dimensional mode. The pros and cons of 2D and 3D modeling will be studied, and at last we will see what is the meaning of computer aided analysis. The preliminary discussion would be carried out. Of course, the detailed analysis or the detailed discussion is out of the scope of this course. But as far as the use of computers in the product life cycle, I thought it is essential to know the budding mechatronics engineers to know how the computers are helping in designing of the products. Well, my friends, as I mentioned in my previous lectures, we need electrical components, we need electronics components for our desired automated system. These components we are selecting based upon the thorough knowledge of the working principle and construction of these components, and then we are procuring these components from the market. But my friends, we also need the mechanical components to build an automated system. The mechanical components may be variety of the links, mechanisms, structure of the automated system, its skin or the body of the automated system. So, all these mechanical components are to be designed, and then we have to take the decision whether these components are to be manufactured in-house or they are to be procured from the outside. So, basically there are 2 aspects. The first is the designing of the mechanical elements, and the second aspect is the decision about fabrication or the procurement. The first option may be we are designing the components in-house, but we are purchasing the components from the market. The second scenario, we have to design and fabricate the components in-house. So, this decision is altogether dependent upon many factors. So, these factors may be the cost associated with the components, that is the primary factor. Second, the availability of the components in the market. A simple example is the fasteners. The standard fasteners such as screws or nuts or the rivets are available in the market. So, there is no point in manufacturing these fasteners in-house. Of course, we can manufacture them by procuring an equipment, but if the components, good quality components are available in the market, it would be wiser to purchase the components from the market and use them for our intended purpose, that is the assembly or the product development. Well, some of the components may not be available in the market, that is the structure of the equipment. So, these components we need to design in-house, and we have to design its manufacturing process, we have to select proper manufacturing process, and we have to go for the actual production of that component. Let me go back to the product life cycle philosophy or the concept that we have seen in our previous lectures. On your screen, you can see the various functions, various operations that we need to carry out during a typical product life cycle. As you can see on the screen, the product life cycle is starting with the marketing. The marketing people will provide the inputs to the design team. So, based on that inputs, design activities will be carried out, and after that the manufacturing activities will be performed. Well, if we group these all activities, we can say that the design need, identification of design need, deriving the design specifications, feasibility study of the design, and the conceptualization, the design conceptualization. These four activities are combining together, and we are saying that we are synthesizing the design. We are getting the design need from marketing team, from the customers. We are specifying that requirements into the numbers, or we are finding out the specifications based on the inputs, that is the need of the customer, and after that we are carrying out the feasibility study, whether it is possible to manufacture the product or whether it is possible to modify the existing design of the product as per the need, as per the requirement of the customer. After that, we have to revise or we have to modify the design, and we have to generate the revised concept, so that we call the design conceptualization. So, these four activities we are clubbing together, and we are calling that process as design synthesis. After conceptualization of the product design, we are analyzing the design, we are applying the mechanical engineering principles, and afterwards we are finding out the optimal design parameters. We are finding out the size, shape, material, and the dimensions of the product by applying the mechanical engineering principle. Then we do the testing or the evaluation of the design, and then we are documenting the design. We are making the documents, we are making the production drawings, and that drawings will be sent to the manufacturing department or the production department for actual manufacturing. The analysis of the model, the designing of the product, optimization, design evaluation, and design documentation These are grouped together and we call this process as analysis of the design. Now we can say that the design synthesis module or the design synthesis activities are analyzing the philosophy of the product development, the objectives of the product development or the modification, or the motive behind development of the product. Then in these operations we are analyzing or we are finding out the intended functionalities of that product and we are defining the uniqueness of that product. The second group of activities that we do carry out are the analysis activities. So analysis activities are dependent upon the engineering analysis. We apply the mechanical engineering principles and we convert the conceptual design into the model or the engineering based model or the prototype. So after testing of this model or the prototype, we can directly go for its production. So in general, what are the various steps to design a mechanical component? So the first step in designing a mechanical component is to identify the design need. So we have to clearly specify the design need. The design need as far as the mechanical components are concerned, we have to identify the size, shape of the mechanical component. So how it is possible? So as I mentioned, we have to apply the knowledge of the mechanical engineering. So what knowledge is required? The fundamental knowledge of the strength of the materials. The strength of the materials deals with the analysis of stresses and deflections in the materials which are under load. To manufacture any product, physical product, we need the materials and we must know how the materials are behaving under the application of the load. The simple example may be the forks of a forklift truck. The forks of the forklift truck are made up of the steel material, but what kind of steel material is required? What should be its strength? So it is very essential to understand and to specify the strength of the material when we are suggesting certain material for the operation. So we cannot have the plastic forks for the forklift truck which is used in the industry application. So certainly we have to go for the steel which is having very good strength. The second, the knowledge that we acquired during the analysis of stresses and deflections will certainly make the design safe. The objective to study the strength of the material is to find out the stresses and deflections so that the design of the product would be safe. We can easily go for the manufacturing of that product. The next important aspect in mechanical design is the application of solid mechanics principle. Solid mechanics comprises of the study of the deformation and motion of solid materials which are used in a product or a system. These solid materials will be under the action of various forces. So when the materials or the components are under the action of forces, as well as the components are moving, they are in movement. During the movement of the components, the application of forces are also there. Study of the deformation under the action of forces and motion will help us to develop a robust product, robust automated system. The third aspect as far as mechanical engineering is concerned, that is the kinematics. The automated systems are having various mechanisms. So we are clubbing various mechanisms and we are developing the automated system that we call the automated machinery as well. These mechanisms are having various links, and these links or these elements are connected with each other through joints. When these links are moving with respect to each other, then what is the transmission of motion and what is the transmission of forces? The principle of mechanical engineering, which deals with the study of motion of a system of bodies without directly considering the forces affecting the motion, that is called as the kinematics. So, the kinematics basically deals with the motion of a particular system or without considering the effect of forces on the motion. By applying these principles of mechanical engineering, the design engineers are getting the final dimensions of the product. Afterwards, we have to go for the testing of the design. To test the design, we have to create either a model or a prototype of that desired product. So, we will see what is the difference between the model and the prototype terms which are used in the product design. The first difference between a model and a prototype is a model shows the appearance of the desired product. So, it does not work. So, when we are saying that I have developed a model as far as the product design is concerned, so that model will just show the physical appearance of the product, the exterior of the product, how the product will look like after its development, that we call the modeling. However, a prototype is the working prototype. So, it will have all the functionalities, it will have all the features which we are trying to incorporate in our product. So, it is a working model of the product that we call the prototype. The second difference between the model and the prototype is, in general, the models are used for the visualization. So, to visualize the size, shape or the appearance of the product after its development, and in general the model is used for the display or the demonstration purpose. On the other hand, the prototype is used for the performance evaluation, performance analysis of the product. Based upon the performance evaluation or the analysis, we can further improve the product before the actual start of the production. During the development of the model, scaling can be applied. The scaling means we can reduce the size of the product. For example, if we are trying to develop an automated guided vehicle, the size of the automated guided vehicle is in meters. However, the final shape of the automated guided vehicle can be visualized by scaling it down. So, by using 3D printer, we can develop a smaller model of the automated guided vehicle, which will help us to visualize the appearance after the development. But in the case of prototype, the model or the prototype is to be the true scale. It should have the exact dimensions as the final product would have. The model will consist of the exterior or the skin of the product. The prototype will have the exterior, that is the skin, as well as it will have the interior parts or the components and the mechanism. So, obviously, as we are developing only skin or the exterior portion of the product, the cost associated with development of a model is less in comparison with the development of the prototype. So, the development of the prototype is having designing and development of its components and assembly as well. Moreover, the development of prototype will take longer time. So nowadays we are using comprehensively the 3D printing, and that 3D printing is coming under the philosophy of the rapid prototyping. So we have to develop first the 3D model, and afterwards the 3D model can be utilized to develop the RP based models. The 3D printing is also used to develop the various components of the prototype. If it is not possible by using the 3D printing, then we have to go for the conventional manufacturing. So if you don't have the metallic 3D printer, but the certain components are to be manufactured by using the steel or the metals. So in this scenario, these components which are made up of the steel, we have to go for the conventional manufacturing. We have to go for casting, we have to go for the machining of that casting. Therefore, the time required to develop a prototype is quite long, it's quite high. So with the use of the 3D printing technology, now it is the matter of few minutes or few hours to develop the skin of a typical product in the scaled down mode. Now there are other two modes as well which are used in modeling. These are the virtual mode of modeling and the physical mode of modeling. In virtual mode of modeling, we are using computers. The computers are helping us to visualize the model in the digital format, the digital modeling, and the 3D printers are helping us to develop the physical models of the product. Of course, the 3D modeling or the digital modeling is convenient and less time consuming, very fast, but we must know or we must acquire the skills required to develop the 2D or the 3D models of the product. So for that purpose, it is essential to have the knowledge of application of computers to develop the 2-dimensional models or the 3-dimensional models of the product. Well, on your screen some pictures are there, and these pictures will give you a better idea about the concept of the model and the prototype. So here you can see the model of a lamp. These lamps are 3D printed. These lamps do have lot of linkages which are connected to each other, but they are not functional, they are rigid, they are not moving. Moreover, these lamps do not have the electrical connections. So these models are simply giving us the idea how the cover of the model or how the lamp would be after the production. Same concept is there for a military aircraft, which you can see on your screen. This is the clay model of the military aircraft, which is developed to know how exactly its physical appearance would be after its development. The third example is a simple bridge with the civil structure. As far as prototypes are concerned, so you can see a robot, that is a very famous robot, Spot Mini. So this is the prototype of the desired final product that we want. It is having all the functions, it is doing all the activities of the final product. Few more pictures or examples are there on your screen, an automotive and one more the robot. Well, as I mentioned to you, to develop the virtual models or to have the virtual modeling, it is very much essential for us to understand the principles of CAD. The CAD is nothing but application of the knowledge of geometrical modeling and computer graphics to solve the design problems. We are applying the principles of geometrical modeling and we are using the computer graphics to visualize the part digitally on the screen virtually. So, this activity is helping us to design the components in virtual mode. So, that is called as the computer aided design. In a similar way, the computers are helping us to automate the manufacturing operation as well. Variety of operations of manufacturing can easily be automated with the use of computers. A simple example is generation of the part programming code, G and M code, which is used in the CNC machining operations. But to generate these codes or to use the computers in manufacturing, we should have the CAD based drawings and we must have the required automation. So, we can say the application of CAD and automation to solve the manufacturing problem is nothing but the CAM. CAM is nothing but computer aided manufacturing and CAD is computer aided design. So, the CAD can be defined as the integration of computer science techniques for the engineering design. The CAD systems require certain hardware and specialized software. So, what are the hardware elements required to have the CAD system? So, we required the input devices and the output devices. The input devices are a typical mouse, a joystick, tracker balls, tablets, digipens or digital pens. So, with these input devices, we are entering the required information to carry out the design operation. And what are the various output devices? A variety of type of displays are available. The LCD displays, LED displays, plasma based displays. So, monitors, then we are having printers and plotters. So, the industrial plotters are of huge size, their size is in meters and they are used to develop the blueprint of the product. So, with these input devices and output devices, we are generating the digital models of the product. After generating the digital models of the product, we are applying various numerical methods. We are applying the knowledge of matrix, the matrices and basic mathematics such as differential equations. With the application of the mathematics, we are finalizing the dimensions of the product. So, to finalize the dimensions of the product, variety of optimization methods are being utilized nowadays. So, these are the classical methods of optimization or the evolutionary optimization methods such as genetic algorithm. Well, now let us look at what are the modes to visualize the product in the digital environment. The first mode of visualization is in a 2D, that is a two-dimensional mode. On your screen, you can see a crank assembly. So, this crank assembly is being shown by using two different views. So for 2D modeling, we need multiple views, more than one view, to communicate the information about the product. It's not possible to communicate all geometric information about the product by just giving only one view. So for manufacturing, for the use of that drawing, we should have multiple number of views, and that is the characteristic of the 2D mode of modeling. So on your screen you can see a typical product, and it also shows the sectional view as well of the product. So the dimensions are provided, and the production engineer will understand the meaning of these dimensions. Well, to manufacture a component, it's not only the dimensions are required. The design engineer should also provide the information about the surface roughness, the tolerances on the dimensions as well as on the features. So it is essential for the design engineer to provide all this information, and once this information is provided, a simple 2D drawing will be converted into the production drawing. So on your screen you can see a typical production drawing. It has two views. So here you can see a sectional side view is provided, and this is the front view. So this is the front view of the wheel, and this is the sectional side view. In addition to the dimensions, as I mentioned, all these are the dimensions, the tolerance values are also provided. So tolerances are nothing but the permissible deviations on the basic dimension of the feature. So this is the 40 is the basic dimension. Positive side, there is no tolerance, there is no deviation is permitted. On the negative side, minus 0.12 is allowed. In addition to this, the roughness values are also provided. Here you can see these are also required to generate the surface finish of the required quality. The production drawings also have the information about various features such as the number of holes and their respective diameters. So when such detailed information is provided as per as the manufacturing of the component is concerned, then we are calling that as a production drawing. The next mode of visualization is 3D modeling. So in 3D modeling, we are using solids to visualize the objects. Solids are having surfaces. The surfaces are made up of curves. So the curves are connected each other, and they are making a surfaces, and the surfaces are stitched together to develop the solids. So on your screen you can see the exploded view of a typical 3D model. So this 3D model has various features or objects, and we are joining them together with certain geometrical location. These features are having relation with the other features, adjacent features, adjuncts. In 3D modeling, we are representing the 3D objects on the 2D plane. So on your screen you can see the variety of ways to visualize the object. So this is the wireframe model, and this is the surface model or the solid model. We can attach colors to the skin of the solid model, and even we can attach the materials. In 3D modeling, we can render the objects, we can have the effects of lighting. A typical surface model of a car skin is seen on your screen. As far as the industrial components are concerned, the 3D models are more effective, they are less ambiguous, easy to understand, and it is a better way of communication. On your screen you can see a piston connecting rod arrangement. So, this is the piston of an engine. These are the rings, these are the piston rings, this is the connecting rod, this is the piston pin which is helping to connect the connecting rod with the piston. There are various fasteners which are used. Well, you can understand that with the 3D model it is very easy for us to visualize the components. It is very easy for us to develop the assembly drawings, the exploded views, or the maintenance related drawings. So, all these types of drawings are based upon the 3D modeling, and that is making the life of the designer and the production engineer easy. In addition to the production drawings or the typical mechanical drawings, the 3D modelings are very much used nowadays for the entertainment purpose. So, here you can see the variety of the 3D models. The 3D models are also used to develop the realistic views of the various products. Well, 3D modeling is also used to design and develop the furnitures and architectural drawings. Well, after the development of these digital models, then we are applying the mechanical engineering principle to test them. So, we are attaching the material, we are applying the forces, and then try to find out the deformation in these mechanical components. So, for this purpose we are using the numerical techniques such as finite element method and various FEM based softwares are available in the market nowadays. So, these are the ANSYS, these are ANSYS or the Abacus. In addition to this, if the product or the system is having the fluid, then there are a lot of the fluid analysis based software also available, such as the Fluent or the Gambit. So, when we analyze or when we carry out the analysis of the products by using the softwares, that is called the computer aided engineering or the computer aided analysis. So, this analysis is very much important to find out the optimal values of the parameters for the intended purpose. It may be mechanical product or the civil product or the architectural product. So, we have to come up with the final values of the parameters. Moreover, the CAD are helping us to develop the process plans or the production plans. Well, let us summarize the lecture. In this lecture, we have seen the difference between the design synthesis and design analysis in the context of the product life cycle. We have seen the difference between the modeling and prototyping phenomena that is used in the product development. We have seen the utilization of computers in designing and development of the prototypes. Then we have seen the difference between the two-dimensional modeling and three-dimensional modeling methodologies, and at the end we have also seen the computer aided analysis, that utilization of the numerical methods to solve the mechanical design problems. In the next lecture, we will look at various fabrication processes, those who are used in the manufacture of the automated system. There are many manufacturing processes. We will be studying the important manufacturing processes such as casting, forming, joining, machining, and the next generation manufacturing, that is the additive manufacturing. So, let us meet in the next lecture. Thank you.